this video we're going to look through the solutions to CCEA's GCSE Summer 2022 M4 paper, which is a calculator paper. Okay, on the front page, first thing to do on the front page is just to read and see what it actually says, what the instructions are, and see if it tells you if there's any significant figures you've got to give the answers to. It says but the candidate number, you're provided with an extra additional support material this year. Just answer questions in paper provided. Do not write outside the boxed area on each page and blank pages. Complete in black ink only. Do not write with a gel pen. Write answer all 21 questions. And it doesn't tell you how many sig figs to do it to. So that's, hopefully it'll tell you it's in the questions. Okay, you're given this formula sheet. That's the standard one you're given every year on the second page. But you're also given, as I say, an additional support material for 2022. We were given some extra stuff with some very basic equations. Okay, we're on to question 1. It says a solid cylinder has a height of 12 centimeters and a circular cross-section area of 34.2 centimeters squared. The density is equal to, so my density is 0.83, and that's grams per centimeter cubed. It says find the mass of the cylinder. So to find the mass, we're going to have to find the volume first of all. So the volume is equal to my cross-sectional area, which I think we have, which is 34.2, times your height, which is 12. So I'm going to work out my volume, doing this on my calculator now. So I got 410. So I got 410.4, and that's going to be centimeters cubed. Okay. Mass is equal to density times volume. So our mass is equal to our density, which is 0.83, times our volume, which is 410.4. So times 0.83, and that gives me 340.632, and that's going to be in grams. Okay, so find the mass of the cylinder. Doesn't give us any indication of how many significant figures to go to, so I'm just going to leave it in as it was. So with the 3 decimal places, it doesn't tell me otherwise, so I should get the marks for that. Okay, question 2 says, shares were bought with an original value of £1,600. The value increased by 5% each year. Calculate this value after 3 years. If something increases by 5%, it goes up to 105%. So 105% as a decimal is 1.05. We're going for 3 years, and that's all we're doing. And so you're doing that in your calculator, 1.05 to the power of 3, and then times 1,600. And I have got, when I've done that, I've got 1,852.2. But because you're dealing with money, put it to 0.20. You can fill that answer in there as well. So 1852.20. Question 3. Okay, right. We've got a frequency distribution here. It says a number of flights delayed at an airport were recorded over 24-hour period. The number of minutes they were delayed is shown in the table below. So you get your minutes, and you've got your number of flights. So this is your frequency column, effectively. And we want to calculate an estimate for the mean number of minutes. I'm just going to look ahead in this question and see if there's anything else we have to do. We might need to use this table. Median. Okay, so you know what? I will split this up a wee bit differently. So right, I'm going to do first thing I'm going to do is my midpoint. My midpoint, and that's going to be x, and then I'm going to do another column in here. I'm going to call it my fx column, and I will do my fx column. And because I looked ahead, they're talking about the median, so I'm going to have a cumulative frequency column as well. So my midpoints, to get my first midpoint, add these two n values, which are 0 and 20, and divide by 2, which is going to give me 10. And then next one is 20 plus 40 divided by 2, it's going to be 30. Next one's going to be 50, next one's going to be 70, next one's going to be 90, last one's going to be 110. So they're my mid values. To get the fx column, that's your f value times your x value, so 31 times 10, and just check all of those. Remember, it's a calculator exam. You're not getting any prizes for doing any tricky stuff in your heads. Just check them all. 19 times 30 I've done on my calculator to give me 570. 10 times 50, don't need to do. It's going to be 500. 14 times 70 is going to be 980. 12 times your 90 is going to be 1080. And then 6 times the 110 is going to be 660. Now what we need for the mean, we need sigma f. So I'm going to add up this column here. We also need sigma fx. So I'm going to add up this column here. So adding up my f column, 31 plus 19 plus 10 plus 14 plus 12 plus 6. And I have added that up and I've got 92. Okay, 31 plus 19 plus 10 plus 14 plus 12 plus 6. Just check it always what you've written in your calculator, and I can see I've done that correctly, so that looks okay. Next thing then is my fx. 310 plus 570 plus 500 plus 980 plus 1080 plus 660 is equal to 4,100. I'm just looking at my calculator and it looked like I'd done that correctly anyway. So it's calculated an estimate for the mean. So my mean is equal to sigma fx divided by sigma f. So my mean is 4,100 divided by 92. And when I did that, I got 44.5652. Okay, that's to four decimal places there. This was our number of minutes delayed. I'm going to go give my answer to so that is going to be 44.57 minutes, and that's the 2 DPs. Okay, next one is a modal class. The modal class is the one that's got the biggest frequency. So you're just looking at this column, seeing which one's got the biggest frequency. Biggest frequency is 31. So they were delayed between 0 and 20 minutes, so which is the shortest delay time. So that's good news for travellers. So the modal class interval was the first interval, which was 0 to 20. Okay, sorry, write the interval as I have done. Was that 0 is greater than, let's say 0 is less than t is less than or equal to 20, I should have said, and write down the interval class which the median lies. Okay, we know there's a total of 92 things, so our median is going to be 92 divided by 2 is equal to the 41st value is where the median is going to be. So in this one, I'm just going to do a running total, so my cumulative frequency, to find out where my thing is. So 31 plus 19 gives me 40. It doesn't give me 40 at all. 31 plus 19 gives me 50, plus 10 gives me 60, plus 14 gives me 74, plus 12 gives me 86, and plus 6 gives me 92. So this number and this number are the same, so it looks like I've done that right. And then I want to find, I've forgotten what I want to find. I want to find the 41st value. So the first 31 values are in here, in this interval, and then the next, this is up to the 50th values in here, so that means the 32nd value all the way up to the 50th value. That means the 41st value is going to be in here, so the 41st value is going to be in this second interval, so it's going to be 20 is less than t is less than or equal to 40. Okay, next question says the graph below illustrates two different monthly tariffs, A and B, for the mobile phone. Tariff A has a fixed charge per month plus a charge per minute for phone calls. And what is the fixed charge per month? So tariff A, so this one here, if you imagine tariff A, you don't use a phone at all, don't use talk to anybody for any minutes at all, you still pay £20. So that means that's a fixed charge that you have to pay, and then any minutes you pay after that, you will be charged for them as well. So £20 is a fixed charge. It says, what is a charge per minute for A? So let's have a look. This is going to be our gradient. So I'm going to use this point here, which is a nice point, and I'll find another nice point. There's a nice point over here. So my charge, my cost per minute, what it has cost me is this. So what is that from 20 to 45 is £25. And how many minutes is that? That's for 1,000 minutes. So £25 cost 1,000, £25 cost 1,000, sorry, 1,000 minutes cost £25. So divide 25 by 1,000, and again do that in your calculator. 25 divided by 1,000 gives you, and so it is, this is in pounds, 0.025 pounds. So leave it as that. That really is what it is. Sorry, we can't leave it as that. That's in pounds, multiply by 100. So that times 100 will give you, and that's 2.5 pence cents. So that's what they have said, because they wanted it in pence there for that one. Okay, I'm guessing we're going to keep using this question because they haven't mentioned our tariff B here. So I'm going to guess, yep, goes on. Write down a formula for the total cost of T of tariff A in minutes. Have they not asked us anything about tariff B? They haven't. What was the point of them having tariff B on this diagram? I have no idea. Okay, hence write down a formula for the total cost of tariff A in minutes. Okay, so your tariff A, total cost T, it costs you a fixed amount of £20, plus for every minute you use, and a minute is M, it costs you 0.25 pence. So I'm going to write that as 20 plus, and remember we've got to have a wee bit of consistency here. So I'm going to keep the units in all in pounds. 0.025 M is what we're going to have. Okay, so just explain what that formula means then. If, for example, I've used the thing for, say, 200 minutes. 200 minutes, then my M is equal to 200. So then T would be equal to my fixed charge of 20 plus 0.025 times the 200. And then we will just go on with that. So that's going to be 20 plus 0.025 times 200. So it will cost you a total of £25. Okay, we don't need any of this. They just want you to write down the bit in blue. So the bit in blue is the answer. I'll follow it in my answer line. I'm just going to write it the other way. 0.025 M, and then plus 20, and that's going to be in pounds. Okay, question 5 says expand and simplify. I'll zoom in on this one. So I just like to use the curly lines here. So x times x is x squared. X times 5 is 5x. Minus 3 times x is minus 3x. And minus 3 times 5 is minus 15. Tidy up, you'll have x squared plus 2x minus 15. X squared plus 2x minus 15. And then we are on to the next question. It says two cyclists start at the same location. One cyclist travels due north at an average speed of 22 kilometers per hour. Another travels due east at an average speed of 26 kilometers per hour. How far apart are the cyclists after 2 hours? Okay, if you're going at this speed for 2 hours, you're going to have 2 times 22. That's going to be 44. That's going to be 44 kilometers is the distance this boy has gone. And this person here has gone 26 times 2, which is going to be 52 kilometers. So that's 52 kilometers this way. And the distance between them, this is just a Pythagoras question. So that's what we've got. So just using Pythagoras theorem then to find this out. So your x squared is equal to 44 squared plus 52 squared. Do that on your calculator. 44 squared plus 52 squared. Press equals. And I got 4640. And then square root of that thing, of that answer, and it came out as 4 times root of 290, and press your SD button, and that got me 68 point, I'll go for 12 kilometers, and that's to 2 decimal places. So 68.12 kilometers to 2 decimal places. Question 7, says simplify 5 minus x plus 10 over 2. Okay, bit of a strange one. This one, I haven't seen one like this in a while. I would take a common denominator of 2 here. So put a wee bracket around this to make it a wee bit easier. So that's minus x and then minus 10. And then the 5, remember, is the same. That's 5 over 1 is the same as 10 over 2. So that just becomes 10 minus the x minus 10. So what happens is the 10 on the top and the minus 10 on the top cancel each other out, just leaving you minus x over 2. Question 8. A factory produces 3 types of light bulbs, clear, pearl, and colour. In a week, 45,360 clear bulbs are produced. Pearl and colour make up 36% of the total produced each week. There are 4 times as many pearl produced as colour. How many pearl are produced? Okay, right. So that means 45,360 is equal to what percentage? We need to work that out. That'll be the easiest way of doing it. So that equals 100 minus 36. So 100 minus 36 is going to be 64%. I'm going to find out then what 1% is, and then I'm going to find out 36%, because that's what pearl and colour together make up. So divide by this by 64. How you get down to 1% is divide by 64, and then you're going to multiply by 36. So if you do that, 45360 divided by, what have I just said, 64, that gives me 708.75. Hopefully when we multiply that by 36 it gives me a nice answer, and it does. So 25515. So that's how many pearl and colour together there are. So that's pearl and colour together. It then says there are 4 times as many pearl produced as colour. So I'm going to do this as a ratio. I think there's other ways of doing this, but ratio to colour then. There's 4 times as many pearl produced, so they're in the ratio of 4 than colour, so 4 to 1. So that means there's a total in this ratio here, there's a total of 5 parts, so 5 parts must be equal to this, and we want to find the pearl, which are 4 parts. So this is a long method I have of doing this, but it makes sense, so people seem to quite like it. So we have this number here is equal to 5 parts. Break down and find out what 1 part is, and then build up and find out what 4 parts is. So if you know what 5 parts is, you can divide by 5 to get 1 part, and then you can multiply by 4 to get 4 parts. So what do we have? 25515 divided by 5 is a nice answer of 5,103, and then times by 4, you're going to get 20,412, and that is your answer. That's your number of pearls, 20,412. This bit here, folks, I'm well aware there's other ways of doing this, but this is the way I like to do it. It just keeps it nice and simple, and they can clearly see what you're doing. Okay, here we go again, right? This is one where we actually had to do a cumulative frequency total. It says 180 year 11 pupils in Glasgow High were asked to record how much time they spent on their phones one Saturday. The results are shown in the table below. So your time in minutes, it's a less than cumulative frequency curve. So there's 6 people in this first interval. All of these 6 people spend between 0 and 30 minutes. So they all spend less than 30 minutes. So they put in a wee column here, which they don't always put in, but this time is less than 30. The next one is less than 60, less than 90, and so on. So it's all just those upper boundaries, basically. 180, 210, 240. Okay. Okay, and then the cumulative frequency, it's a running total of the frequencies. So it's a running total of your frequencies, just so whatever they're going to be, 6 plus 10, oh, big mistake there, 6 plus 10, you add the next frequency. So 6 plus 10 is going to be 16, plus 25 is going to be 31. So what are we on? 31 plus the 37. I would just check these on your calculator. It's so easy to make a mistake in these. And again, you don't get any prizes for doing anything in your head in these exams. So 100 plus 29 is going to be 129. Can't believe I did that one on the calculator. Plus 27 is 156. And plus 14 is equal to 170. So this is quite a nice number. That would sort of make me think that I've done that correctly, because typically they are quite nice numbers. Not always, but if you did get an answer, say you get an answer of 173, I definitely would be adding my numbers up again to check that I've done that right, because typically they are nice numbers in these things. Okay, complete the cumulative frequency table. We've done that. Right. Next thing we're going to have to do is actually draw this thing right. I'm going to have to do a lot of clicking back and forward. I'm going to do the first couple of points, and then I'll just do the rest of them. Pause the video, do the rest of the points, and then come back to it. Okay, so the first point we have to do, we've got 30, and the corresponding cumulative frequency is 6. So on our time axis, we're going to 30. I'll zoom in so we can see this. So 30 is going to be halfway between the 20 and the 40. So 30 is here. And each wee square, you've 10 squares are worth 20, which means 1 square is worth 20 divided by 10, which is worth 2. So 6 is going to be 3 wee squares up. So that's where you put your first point. Okay, the next one then we have to do, and this is the last one I'll do now. I'll pause the video and get these all drawn in. So the next one we have to do is 60 and 16. So again, 60 is here. 16 would be 5 squares would take you up to the 10, and then 1, 2, 3 more. So this point here, and then right, there's how we've done the first two. I'm going to pause the video and do the rest of those points, and then we'll come back to the video. Okay, I've got my points all drawn. You can see they take this general shape, so it's sort of like a nest shape almost is what they do. I'm going to have a go at drawing these now, so not easy to do on this thing. So a wee trick for drawing curves is as you're drawing to one point, cast your eye to the next point, and it sort of smooths it off a wee bit. So I'm going to say that I'm going to mess this up. So right, so I've done my cumulative frequency curve. It's not good at all. I have to say I've done as best I can. This is not easy to draw on this thing, but there it is. So I'd imagine these are not too accurate. It says use your graph to estimate the median. Now, so we've got 170 things in total here. So your median, the position of the median as well, another way of saying the median is Q2, lower quartile will be Q1, upper quartile will be Q3. So we have 170 values divided by 2. So 170 divided by 2 gives you 85 values. So we're looking for the 85th value. 85 is not your answer. We've got to work out what the 85th value is. We're going to do that using our graph. So this is 80. This would be 90. So 85 is going to be here. So I'm going to use this thing. And this is why it's so important that you show you're working out. You've seen my graph, which is very, very bad. It's not good. But even from this, if I've done my graphs, and maybe I don't get my full marks from a graph, I will get my full marks if I show my working out. So this is what I mean by showing my working out here. So here, this is where it meets the graph. I'm just going to go down from here and see what I get. So there's where it meets there. So whatever that's going to be, 126. No, it's not 126 at all. Sorry, 4b squares. 4b squares is 20. 5b squares is 20, sorry, so 20 divided by 5 is 4. So we're 3 squares, 3 times 4 is 12, so it's going to be 132. Took me longer than it should have there, so 132 is my median, so 132 minutes. For your interquartile range, you need to find your lower quartile, which is just going to be 170 divided by 4 is the position of it. So 170 divided by 4 gives me 42.5. That's what the value is, and we can work that out. For your upper quartile, it's 3 times the 42.5, so just times that by 3. That's going to be the 127.5 value. We've got to use your graph to find those things and then take it away from each other. So it's a fair bit of work for just two marks here. So we'll do the lower quartile one first. 42.5. 42 would be here. 42.5 would be, that's 44. So 42.5 is roughly here. It's not easy to do this at all. So you do this as best as you can, really. Slightly above that line I'm going across. Same whatever I meet. And again, it's not perfectly accurate. And going down here, we've said in the last part there that it was four units for every box on the horizontal. So that's going to be one box past 100 is going to be 104. Next one was 100. Q3 was 127.5 value. So 127.5 value. So we'll zoom in on this again. That's going to be 122, 124, 126, 128. So 127.5 is somewhere along here. So let me zoom out again. And there we have it, right? I'm just going to label those. That's my Q3, that was my Q2, and that was my Q1. So my Q3, sorry, my last one here. I'm guessing it, I'm going to say it meets bang on that line, so I have somewhere nice to go down from. Okay, so we've gone down here, and that's four units shy of 180, which is going to be 176. So 176 minus 104 is going to be 72 minutes. Right, that took a lot longer than I thought it would. It says the staff at the same school were asked to record the times they spent on their phones on the same Saturday. So remember, this was the first thing was school children. This is now the staff in the school. Their results are recorded on the box plot diagram. Compare the results of the pupils and the staff. Okay, so let's just work out what for the staff then. What's my median? So my median is going to be 84, and my lower quartile for the staff is going to be 56. My upper quartile for the staff is going to be 132. So my interquartile range for the staff is 132 minus 56, which is 76. Okay, let's compare that with what we have earlier on. So for the pupils, the median was 132 minutes, and their interquartile range was 72. So they're fairly equally spread. However, as their interquartile ranges are fairly similar, however, the pupils clearly spent a good bit longer on their phones. Okay, so we have to try and get three comparisons. First one will say the median for the pupils is much higher. Interquartile range were fairly similar, we'll say, fairly close. And one more, right? Let's maybe look at the upper values and the lower values. Yeah, there's not really much else in it, is there? 140. I would just give a generalization then of what's going on. So it means generally the staff spent less time on their phones. Okay, so if their interquartile range is fairly similar, so you can see as well, and let's have a look at one more thing. We'll look at the lower quartile for the lower quartile for the pupils is 104, whereas a lower quartile for the staff is only 56. So they are well lower, actually, the staff, what the amount of time they're spending on their phone, which is good to hear. Okay, question 10. We have got, this is a strange looking question here. We've got an algebraic sum. What would be the best way of doing this one? A couple of ways you could do this one. You could just multiply it out and go with that. That would work. I think maybe what they want you to do is to make it into like an algebraic fractions type question. I'll do the algebraic fractions way first, and then I'll show you the other way, which you probably will prefer in this instance. But what you could do, if I bring the fraction bits across the one side, so I'll have 1/4 times y plus 3, and then minus 1/2 times 3 minus 2y, and I'll bring this 2 here as minus 2 across, and it becomes plus 2. Then how you would normally have this question set up would be y plus 3 all over 4, and then minus of 3 minus 2y all over 2 is equal to 2. And what you would do then is take a common denominator. Common denominator would be 4. So use a few brackets here just to keep yourself right. So y plus 3 minus, this second fraction was over 2, so it needs to be multiplied by 2, top and bottom. And that's what you have. And then I would multiply across by my denominator. So it gets multiplied across, leaving you y plus 3. And I'll leave that in a bracket. Oops, sorry, that's minus 2 times 3 minus 2y is equal to 4 times the 2, which is 8. Okay, so that's what I was doing there. And now we're into just multiplying out our brackets. We've got y plus 3 minus 6 plus 4y is equal to 8. Tidy that up, you'll have 5y minus 3 is equal to 8, which means 5y is equal to 8 plus 3, which means 5y is equal to 11, which means y is equal to 11 divided by 5, which is equal to 2.2, okay, or 2 1/5. All right, so that's, I'm not even too sure if that's the way they would want you to do it, but that will get you your marks anyway. I'm going to look at a slightly different way of doing this question then, which you may prefer in this one, in a weird one, I guess, where you just multiply out the brackets. So if you just multiply out, you're going to have 1/4 y plus 3/4, then minus 2 is equal to 1/2 times 3 is just going to be 1.5. I'm just going to write that as, 3 over 2, actually, just 3 over 2 is fine. And then 1/2 times a minus 2y is minus y. Bring all the y's to one side, you'll have 1/4 y plus y. Everything else clears over the other side, so you have 3 over 2, then plus 2, and then minus 3/4. On your calculator, do 1/4. 1/4 plus 1, and it gives you, it comes out as 5 over 4, which is 1/4, remember, y. And then over here, you've got the 3 over 2, and then plus 2, and then minus 3 over 4. Press equals, you've got 11 over 4. And this is a calculator exam, so you just do it. You could, I'm going to rub this out in a wee second, but you could get rid of the 4's there. So 5y equals 11, which is the same as this line here, so you can see it's working. But it's a calculator exam, so you don't even need to be not caring about it. You can just say y is equal to 11 over 4 divided by 5. Oops, that's a 5, believe it or not, over 4. Fire that into your calculator and you will get 2.2. So probably in this instance, the method I've done in black is the easier way of doing that question. Okay, question 11 says u has coordinates -1, -1, and v has coordinates 2, 5 as shown. So there's your, there's your u, your v, sorry, and your u. Find the equation of a straight line joining these two things. So I'm going to write down with their coordinates again. What was u was equal to -1, -1, and v was equal to 2, 2, 5. Okay, so the gradient, first of all, is equal to your y difference over x difference. So 5 minus -1 over 2 minus -1, which is going to be 6 over 3, which is 2. So the equation so far is y is equal to 2x plus c. To find your c, sub in a point. I'm going to sub in a nicer of the 2 points to 2, 5. So 5 is equal to 2 times 2 plus c. So 5 is equal to 4 plus c, which means 1 is equal to c. And your last line, remember to rewrite your equation with your constants in it. So y equals 2x plus 1. Next one says, find the equation of the line perpendicular to uv that passes through the point 0, -1. Okay, its gradient, first of all, if it's perpendicular to this one, if it's perpendicular to this line here, this line uv had a gradient of 2. So if you're perpendicular, you've got a negative reciprocal, so -1/2 is what your gradient's going to be. So far, y is equal to -1/2 x plus c. Then you sub in your point 0, -1. So when when x equals 0, y equals -1. So -1 equals 1/2 times 0, which is just 0, plus c. So your c is equal to -1. So your line is -1/2 x -1. Okay, question 12 says, find an expression for n for the difference between the area of, find an expression in n, for the difference between the areas of the two squares. So your first square, call that area 1, area 2. Area 1 is going to be equal to 4n plus 3 upon 4n plus 3, which is going to be 16n squared plus 12n plus 12n plus 9. Tidy that up, that's going to be 16n squared plus 24n plus 9. Your area 2, what's it, 3n plus 4? Area 2 is going to be equal to 3n plus 4 upon 3n plus 4. If you multiply it out, you're going to get 9n squared plus 12n plus 12n. 12n plus 12n plus 16, which is going to be 9n squared plus 24n plus 16. So the difference between them, what we're looking for is a1 minus a2, which is going to be equal to 16n squared plus 24n plus 9 minus 9n squared minus 24n minus 16. And if you do that out, 16n squared minus 9n squared is going to be 7n squared. 24n minus 24n disappears, and 9 minus 16 is going to be minus 7. Okay, question 13 says the diagram shows two vertical mass, A and B. A is 210 meters high and B is 1.5 times the height of A. So let's just do those, work those out. So that is 210. 210 times 1.5 is 300, so it was meters, sorry. Meters, and that's going to be 315 meters. The angle of depression from the top of B to the top of A is 25. Okay, we're going to do a diagram here. So the angle of depression, if I make that a wee right angle triangle, there we go, and that is 25. So 25 is this angle in here going downwards, and calculate the horizontal distance between the two masses. We need to find this wee distance. First of all, we can find this wee vertical bit in here. That's going to be 315 minus the 210, which works out to be 105 meters, and then we're good to go. So I'm going to draw that out again. That's 25 degrees. That's 105 meters. That's my x. So we'll say our tan theta is equal to opposite over adjacent. So in this case, tan, there's my opposite, I should have said, and there's my adjacent. So tan of 25 is equal to 105 over x. So it's the trickiest type of one of these. Multiply across by your x. X times then tan of 25 is equal to 105, which means x itself is equal to 105 divided by tan of 25, which means x is equal to, do that in your calculator, 105 divided by tan of 25, press equals, and you're going to get 225.17 meters. I've gone to 2 decimal places. Okay, question 14 says solve this thing, giving your answer correct at 2 decimal places. We could just solve this nicely, actually, just without doing sum of product or anything like that. We could just say x minus 2 is equal to plus or minus the square root of 10, which means x is equal to 2 plus or minus the square root of 10. There's absolutely no reason why not in this question, yeah. Unusual, but yep, you could do that. And then that means 2 decimal places, 2 plus the square root of 10. Sorry, x is equal to 2 plus the square root of 10. Is equal to 2 decimal places, 5.16 to 2 decimal places, or x equals 2 minus the square root of 10. So x is equal to minus 1.16, again, to 2 decimal places. Ooh, a circle theorem one here, everyone's favourite. It says P, Q, and R are points on the circumference of the circle. Centre O. The line ST is a tangent to the circle. And it says PRS is 65 and PRQ is 53. Calculate the size of the angle POQ. Right, where is POQ? POQ is in here. Right, question I guess, mark on anything you know. So I know that's a radius and that's a radius, so they're going to be equal. And what else do I know? PRQ. So PRQ is 53. So this angle in here is 53. This is the angle which comes from P and Q, and it's at the circumference. So the angle that I'm looking for is at the centre, and it's twice. So it's going to be 2 times that, so it's going to be 106, because it is the angle at the centre is twice the angle at the circumference. I'm squeezing this in, apologies, at the circumference. Okay, next thing we've got to do is calculate the size of the angle OQR. Where is OQR? OQR. Okay, so we want this wee angle in here. Right, let's mark on what we just found out. I've just found out that this angle in here is 106. So because this angle and this angle are going to be the same, so to find that wee angle in there, it's going to be 180 minus 106 and then divide by 2. So it's going to be equal to 37 degrees. Okay, so that was 180 minus 106 and then divided by 2. That's how I've worked that one out. Okay, so that's 37. But we want to find this this angle here, the one in here, so OQR. Right, by the alternate segment theorem, this angle is 65, which means this whole angle is also going to be 65. So I'm going to say PQR equals 65 degrees, and that's by the alternate segment theorem. That's how I've got that. Okay, and then the other angle we're going to look for then, this angle in blue, is just going to be 65 minus 37, which is equal to 65 minus 37, 65 minus 37, which is 28 degrees. Okay, so we have to now put that all in. So calculate that, giving a reason for each step. So we can say that the angle, first thing we did was did a bit in black, so PQR. So PQR is equal to 180 minus, 106 divided by 2. Let me just check that again. 180 minus 106 and divided by 2, yep, was 37. And then the next thing we did was a bit in red. We found our whole angle, so PQR equals 65. PQR is equal to 65 degrees, and that was by the alternate segment theorem. And then the last bit, the bit that we're trying to find then, therefore OQR is equal to 65 minus 37. So 65 minus 37 was 28 degrees. Okay, question 16 says the table given gives information about the numbers of hours worked by employees of a factory in 1 week. No employees work more than 50 hours. So first thing you've got to do, it says complete the histogram for this information. So a histogram requires you to have frequency density. So we're going to do a frequency density column. And how you get your frequency density, it's a frequency divided by the class width. So from 0 to 5 is 5. So you're just doing 6 divided by 5. And if you do 6 divided by 5, give it as a decimal, you'll get 1.2. The next one is 32 divided by, from 5 to 10, 5 to 15 is 10. So 32 divided by 10 is 3.2. Next one is 54 divided by 15 will be 3.6. And 75 divided by 15 is going to be 5. And 16 divided by 5 is going to be 3.2. I'm going to just count up the frequencies because I know there's a stratified sample bit later on, so I'm going to count up the frequencies, and that is 183. Okay, we've now got these frequency densities. Let's see if I can leave that on the screen there, the two of them. There we are. So we've got your frequency densities, and you can see then the first bar, which is from 0 to 5, this wee bar here, from 0 to 5, its height is 1.2. So 6 wee squares is 1.2, which means 5 wee squares must be 1. So it allows you then to put markings onto this axis here. So there we have it, and then you can go ahead and you can draw your diagram. So the next, fill in your histogram. So the next one is from 5 to 15. It was, the frequency density was 3.2. So 5, there's 15, and you go up to 3.2. Okay, so you do your second bar then, which was height 3.2, and it was from 5 to 15. So you mark that on. I'll just do one of these and I'll pause the video and fill in the rest of it. And then the next one was from 15 to 30, and it was a height of 3.6. So there's 3.6 is going to be here. Again, there you go. You can just speed through all of that, and there we go. I'll just pause this video and do the rest of it here. Okay, so you can see I've got the rest of them done. And a handy thing to do is just to mark on the frequencies. As again, we'll see there's a stratified sample bit coming up, and it's handy to have the frequencies marked on. So the first one was 36, the next one was 32, next one was 54, the next one was 75, and the last one was 16. Okay, so you've got all of those there. They're all marked on. The next bit says, it's a sort of strange wee question. It says, to investigate the link between job satisfaction and the number of hours worked, explain why a stratified sample is the best method to use here. The long answer really is because people who work more hours may have more or less job satisfaction than people who work less. So these people up here, for example, I don't know if they have more or less job satisfaction, but they're probably going to be different than a different attitude than the people down here working very few hours. So that really would be one reason. So you want to get a fair representation of the whole population. So, but the answer that I think they would be looking for is something along those lines, that just a stratified sample gives a fairer representation of the population when there are definite groups. Okay, so what that means then, you should know then that if you've got definite groups, then means that the population is going to be sampled in proportion to, so for the bigger group here, so this group here, for example, which has got 75 people in it, it should be the one that has got the most people in the sample. And I think that's what the next part of the question looks at. Okay, next part of the question says, a stratified sample of 30 employees is taken from this data. So that's 30 out of, and this is why I got you to do this earlier on, 30 out of 183 employees are sampled. And a stratified sample of 30 employees is taken from this data. Calculate an estimate for how many employees in the stratified sample work more than 36 hours. So what I want to do is, out of my, from this thing here, I'm going to look and see where 36 is. I'll rub that out, that mess that I've made here. So 36 hours would be in here. So it's going to be bang on this bit. So out of all this bit, we need to work out how many people are in it. So we've got more than 36. There's definitely 16 in here. We need to work out how many's in this rectangle that's been divided off with the black line here. So there's 72 in this bit, 75 in this bit, so it's 75 times. And what fraction of that whole rectangle is it? It is going to be, the whole rectangle is width 15. And we have got with 9 out of the 15 there. So if you do that in your calculator, 75 times 9 over 15, you're going to get 45. Okay, so we now know we're looking at the number in the population then. So the number in the population, in the whole population, which have greater than 36 hours, or work greater than 36 hours, is going to be equal to 45 plus 16, which works out to be 61. Now, it's at 61 out of our total, which is 183 times 30 is going to give you your answer. And if you do that, you will get just 10 people. So there's 10 people are sampled, and that's it. Okay, next one we've got to do is factorize this thing. So this is the difference of two squares, as 25 is 5 squared and 0.01 t squared is 0.1 squared. So you can factorize this thing using your difference of two squares. X squared minus y squared is equal to x minus y upon x plus y, which means this thing factorizes to be 5 minus 0.1 t upon 5 plus 0.1 t, and that's it. Okay, next one's fairly tricky factorization question. Normally what you would do is you would factorize the first two terms completely and then factorize the second two terms completely. But if you look at your first two terms, there isn't a common term here, so you can't pull anything out. So what you're going to have to do is rewrite this thing and just swap a term around. So I'm going to swap the middle two terms around. And then I'm going to factorize the first two terms completely. So I can pull an a outside, leaves me b minus c. And here I can pull out positive d, and that would leave me minus c plus b. Now I had hoped that my two brackets would be the same. They're not, they don't look the same, but they are actually the same. Because if you take your second bracket and just reorder the things, you will have b minus c. and then write down your common bracket, which is b minus c, and then what's in front of it? A and a plus d, and that's your answer. So b minus c upon a plus d. Okay, question 18. I think this is probably the hardest question in the paper. I didn't really like this question, I have to say. Confused me a wee bit. It said an employee of a company earns £260 per week for a basic 40-hour week. She is offered a 10% rise in her hourly rate. She is also offered a percentage reduction in her working hours. So she gets a 10% pay rise, but she also works a certain reduction less of working hours. But the combined impact of these changes is a 4.5% increase. So she's working less, but because of the pay rise, she's still getting 4.5% extra. Okay. What I'm going to work out is her new pay if she's still doing 40 hours. So what that would be. Okay, so it was originally £260 she got for her 40 hours. And if you increase that by 10%, by multiplying by 1.10, you will get £286. So that would be if she was working those 40 hours, that's what she would be getting paid. Okay, now she doesn't get paid that because she also, she doesn't work those 40 hours, so she's going to get a reduction. Okay, her actual pay for, and I don't know how many hours it is she's working, I'm going to say for n hours, is equal to, so it was a 260. And remember, it says the combined impact of all these changes is a 4.5% increase. So multiply that by 1.045, which is equal to £271.70. Okay, so that's what her actual new pay is going to be. So let's just work out what the increase then is, or sorry, we'll say what the reduction is then. So to find the reduction, this one here, this is what her pay should have been had she kept working in the 40 hours. But this is what her pay actually is. So we're going to work out what the reduction is. So basically, what is the difference between them? So reduction, we'll just say, is equal to the difference between that, 286 minus 271.70. And if you do that, work it out, that's going to be £14.30. So that's what the reduction is. So we'll just say her percentage reduction then is equal to £14.30 divided by 286, and then times 100%, and then that is equal to 5%. Okay, and if I got 5% as an answer, I'd be pretty confident it is right. Right, okay, I'm going to go through and show you why that this does work, that this is actually true. So her new pay, basically we need to get that our new pay is going to be this thing. So just to prove this, and I probably would do this in an exam, just to check one, I guess, where it's a wee bit odd. Okay, so she originally worked for 40 hours. I'm going to work out, first of all, how much her original hourly pay was. So her original pay was £260. If we divide that by 40, we'll get what her hourly pay was. So 260 divided by 40, and that gives you that she was getting £6.50 per hour. So if that's increased by 10%, you would multiply by 1.10, and then she normally does 40 hours, but then that's been reduced by 5%, and to reduce something by 5%, you'll multiply it by 0.95. Now if you do all of that in your calculator, we should get the thing that I've got circled in red. You should get £271.70, so fingers crossed that works. So 6.50 times 1.10 times 40 times 0.95, press equals, and thankfully I get £271.70. So that is something I would do at the end of an exam just to check my working out But the bit in blue really is what you need to do to answer this question. The bit in red is what I've done just to check that I am actually correct. And thankfully I was. Okay, this one is a very, very nice question, but I know a couple of people had said to me after the exam about this one. It's actually a very, very nice question, as nice a frustum question as we're going to get, really. We've got a lampshade is made by removing a small cone from a larger cone, as shown in the diagram. The volume of a frustum basically is when you've got a big cone, and then you chop off a smaller bit of the cone, so you chop off the pointy end, basically. That's how you create a frustum. So, the volume of a frustum is equal to the volume of the big, I haven't written cone, but the volume of the big cone minus the volume of the small cone. So we're told in this question that the volume is 16625, and the volume of the big cone, remember the formula for the volume of the cone, it is a third times pi times r squared times h. So it's a third times pi times my r, which is 2r squared, times my h, and the height of the big cone is 56. Volume of the small is a third times pi times r squared times the height of the small, this wee dimension here would be 56 minus 28, which is actually 28 again, times 28. And then if you just tally that up, you'll get 16625 is equal to 224 pi over 3 r squared minus 28 pi r squared over 3. I'm going to run out of space here, I think. That works out as 16625 is equal to 196 pi over 3 times r squared, which means 16625 divided by, calculator exam, don't have to, just use your fraction button here, don't have to do any fancy working out, is equal to r squared. And that means you get a number, and then r is the square root of that number, and the number I had was 782. So when I did that, I got r was equal to 8.999916545. So r is equal to 9.00 centimeters, and that's the 2 decimal places I've given it to. Okay, 2 more questions to go just. Right, tough enough question, this next one, I thought. It said, sine p, if sine p is equal to sine r, show that, and then you've got this equation. Right, you're not going to read this question and know how you're going to get to this answer. That's not how this works. But you're going to see sine p and you're going to see sine r, and then what should be happening in your mind is you're thinking, well, what is sine? So we've got a right angle triangle. Remember back to your old SOHCAHTOA. And we'll just write down that sine theta, whatever the angle is equal to your opposite over your hypotenuse. So you can set up an equation with sine p. So sine p is equal to its opposite, which is 6x plus 5, over its hypotenuse, which is 12x plus 31. And you can do the same with your r. Sine r is equal to its opposite, which is x, over its hypotenuse, which is 5x minus 1. Now it tells you that sine p equals sine r. So that tells you, therefore, that 6x plus 5 all over 12x plus 31 must be equal to x over 4x minus 1. Okay, and we're going to run out of space fairly quickly here. So what we want to then just do a wee bit of cross multiplying. So you'll have 6x plus 5 upon 4x minus 1 is equal to x upon 12x plus 31. And then if we multiply that out, I'm going to have to zoom in and do this so I can actually get this squeezed in. You're going to have 24x squared minus 6x plus 20x minus 5 is equal to 12x squared plus 31x. Bring it all to one side, put it equal to 0, so bring it all to the left hand side. You'll have 12x squared minus 17x minus 5 equals 0. And sure enough, wasn't that what you were looking to find? So it's a great question because you know you've got the full 4 marks. Okay, so not easy, but if you get started it's also not too bad if you just get started. Okay, hence calculate the size of the angle P. So if you knew what sine P was, here's sine P here. If you could find a value for sine P, so say you knew sine P is equal to 1/3, I don't know what it's going to be. So you knew sine P was equal to 1/3, then you could find what P was. So we're going to have a wee look at this and see. So if we solve this thing, we can find the x. And if you solve x, then you can find a value of sine oops, I've highlighted the wrong one there, of sine P. And then that means you can then in turn find P. So first thing we're going to do is solve the equation 12x squared minus 17x minus 5. So just write that down again. 12x squared minus 17x minus 5 equals 0. We'll do the old sum and product method. My sum is minus 17. My product is minus 60. So my two numbers are going to be minus 20 and positive 3. So we'll say 12x squared minus 20x plus 3x minus 5 equals 0. Factorize out, pull out a 4x, leaving you 3x minus 5 plus 1 upon 3x minus 5 is equal to 0, which means 3x minus 5 upon 4x plus 1 is equal to 0. Wee bit of working out, it means x equals 5 over 3, or x is equal to minus 1/4. Now, have a look. This will save you a lot of time and heartache here if you look at this. X is a length, so x cannot be minus 1/4. So you can get rid of that one. So all you have to do, you don't have to write down any explanation of why not. You just have to say it is not possible. So we can move on with just this one here as our answer. The x is equal to 5 over 3. Okay, we know from earlier on, remember we had that sine of P was equal to 6x plus 5 all over 12x plus 31, which means sine P now is equal to, and use your fraction button on your calculator to do this, so 6 times 5 over 3 plus 5 all over 12 times 5 over 3 plus 31. Put that in and it should tidy up to be 5 over 17. And then it means P is just equal to sine to the minus 1 of 5 over 17. Excuse my terrible handwriting. Which means P worked out to be 17.10 degrees. And again, I've gone to 2 decimal places. So a tough enough question, but you do have to just get started. Okay, last question. Right, wasn't too happy with this question. I thought this was a harsh question. It was worth 6 marks. It's not an overly difficult question once you get into it, but a lot of people just would not have got started this question. So it says, given that this equation has a solution of x equals 3, find the possible values of a. So what people are not going to get is that if something has a solution, that means x equals 3 works in it. All right, so when you put x equals 3 into this left-hand side, it's going to come out as an answer of 1. So that's really what it is. That's really what your first step's going to be. So you're just going to rewrite the thing. But everywhere you see x, you replace it with 3. But I know that will confuse people. So just say rewrite as 2 over 3 plus a minus 5 over 3 minus a is equal to 1. And then this is an algebraic fraction question again. So you've got 3 plus a upon 3 minus a. All I've done, sorry, I didn't say what I was doing there. Take a common denominator. And then you're going to have 2 upon 3 minus a minus 5 upon 3 plus a. And remember your brackets. That's where people go wrong in this. And then what I'm going to do is multiply across. My right-hand side gets multiplied by the denominator. So 3a upon 3 minus a. Hopefully you see that that's the difference of 2 squares. And then we're going to multiply out our numerator here. So multiply this out, see what we get. You're going to have 6 minus 2a minus 15 minus 5a. And then that works out to be minus 9 minus 7a is equal to, and remember I've said that this right hand side, that's the difference of two squares, x plus y, x minus y, so it's going to be x squared minus y squared, which in this case works out to be 9 minus a squared. And then we'll bring it all to one side. I like to bring it to the side that makes the a squared positive. So that's what we have. And then this can factorize. My sum is minus 7 and my product is minus 18. So two numbers such that they add to give minus 7 and multiply to give minus 18 are minus 9 and 2. So it factorizes to be a squared minus 9a plus 2a minus 18 equals 0, which means a upon a minus 9 plus 2 upon a minus 9 equals 0. Almost there, which means a minus 9 upon a plus 2 is equal to 0. So put this bit equal to 0, so you'll have a minus 9 equals 0, which means a equals 9. Put this bit equal to 0, you'll have a plus 2 equals 0, which means a equals minus 2. So your possible values are a equals 9 or a equals minus 2. Okay, and that is the whole thing done. Just always check. It definitely says this is the end of the question paper, and always turn over the pages just to check that you haven't missed anything.